So we're taking a look at 1.4. Let's take a look at example 1. What we want to do is we want to use our form fx equals a open parentheses x minus h close parentheses to the power of 2 plus k to find our vertex, axis of symmetry, and our minimum or maximum value. And this graph looks something of this nature here, where it looks like at -1 and 2, we have this point, and it looks like it goes something like this. So our vertex is really nice. Our vertex is the lowest point or the highest point on the graph. So vertex here is -1 and 2. All right, this axis of symmetry. All right, axis of symmetry is always the x value of the vertex. And it's always an equation. So axis of symmetry is always, let's say, let's go back a little bit. Let's say what it is, it's axis of symmetry is always x equals the x value of the vertex. So it's x equals, our x value of the vertex is -1. So axis of symmetry is x is -1. Here it has a minimum. Oops. The minimum value is the y value of the vertex. Y value of the vertex is 2. So here this answer is 2. So example 1's a really nice example. Let's take a look at example 2. Example 2, a little bit more interesting. They give us this equation. F of x equals x squared plus 10x plus 32. And the first thing they want us to do is find the vertex. All right, there's two options of finding the vertex. What you can do in order to find the vertex. So to find, you can complete the square, which is shown on view an example. But another option is to find the x value first. And we find the x value by using a formula, right, which is x equals -b over 2a. Right, so we can use this formula in order to find the x value. So our equation is f of x equals x squared plus 10x plus 32. Here it should be clear that your a is 1, your b is 10, and your c is 32. So we find our x value by replacing. So it's -10 over 2 times 1. Right, this here is going to give us a -10 over 2, which gives us -5. So that's the x value of the vertex. So now to find y, you evaluate the function, right, by replacing x with -5, right? And replace it with -5 because that's what we found there, right? So if we had x squared, we can rewrite it as y instead, equals x squared plus 10x plus 32. So now we replace each x with -5. So we get y to equal, this is a 25, this is a -50, plus a 32. We get our y value to equal, what do we get? 25 minus our 50 plus our 32. We get our y to be 7. So our vertex here is -5 and 7. Okay. So that was part A. Part B, axis of symmetry. We talked about that already. We said it's x equals, and it's x equals the x value of the vertex, right? So this is just going to be -5. So now the question is, does it have a max or minimum value? Part C. Right, so in order to determine if it has a maximum or minimum value, we take a look at our A value, okay? Right, if our A is positive, that means the graph opens up and it has a minimum value. If your A is negative, it opens down, and that it means it has a maximum value. So remember, our function was x squared plus 10x plus 32. Here your A is 1, therefore it's positive, therefore it opens up, so it has a minimum value. And what is the value? We talked about this a little earlier, right? Once again, the minimum value is the y value of the vertex. So here our vertex was, y value is 7. So the minimum value here is 7. Okay, and the last part, part D, we need to graph. We need to graph this function, right? So in order to graph, we need to find 2 additional points. We choose 1 to the left of the vertex, 1 to the right of the vertex. So I like to make a table here, right? We have x, we have y. We know what our vertex is because we found it, right? Our vertex was what again? It was -5 and 7. So we already know that point. -1, 2, 3, 4. -5, 1, 2, 3, 4, 5, 6, 7. Right? So we have -5, and we have 7. We want one point to the left, right? We want a point. We need, it says, in order to graph, in order to graph, we need to find 2 points, one to the left, one to the right. So pick X to the left, pick X to the right. And remember, this is your X. So what's an X to the left? How about -6? What's an X to the right? How about -4? All right, so now all we do is just plug that into our equation. Remember, we had fx, or our function was this, right? First, let's do it for -6. Replace each x with -6. All right, so we get what? 36 minus 60 plus a 32. We get 8. So that's another point. -6 and 8. And we do it again. This time x is -4. And we replace x with -4. So what do we get here? This is 16 minus 40 plus a 32. And we also get 8 there, right? So at -4, we get 8. So we see our graph looks just like this. If you see that these numbers are not nice, pick a different x value. Remember, we can pick anything to the left and anything to the right. So if you get a fraction, a decimal, too big of a number, just pick something different. So that is how you should work the rest of these problems here. We can also find the range, the domain, if we wanted to here as well. Let's take a look at this a little further, right? So, right, our points were -1, 2, 3, 4, -5, 1, 2, 4, 5, 6, 7, 8, right? So what we had is this point here, we have this point and that point. Looks like that. Your domain for quadratic functions is always -infinity to +infinity. Right, so that is our domain. The range All right, remember range is your y values. Oh, let's not forget domain stands for x values. Range is the y values. So if we take a look here, when the graph goes like this, it will always be open bracket y value, comma, infinity with parentheses. If a graph looks like this, it will be open parentheses, negative infinity, comma, y value. And let's say y value of vertex. Close bracket. So this range, it opens up. So the y value of the vertex, what do we find our y value of the vertex? It was 7, right? So our range is 7 bracket to infinity parentheses. We can look at when it increases and decreases, right? Taking a look at it again. 1, 2, 3, 4, negative 5, 1, 2, 3, 4, 5, 6, 7, 8. All right. So when it increases, should look like a line with a positive slope, right? So it should look something like this, right? And what we see is from here, it looks like it's going up, right? So when it's increasing, right, we look at our vertex. This value, remember, was a negative 5. So it looks like it's increasing from negative 5 to infinity. Decreasing looks like this. All right, and that's what we see on this side. All right, a line looks like it's going down. So this is showing the decrease side. This is showing the increase side. So decreasing looks like it's from negative infinity to negative 5. And if you notice, both of these, right, will always have, the x value of the vertex included. So a nice summary of 1.4. If you have any other questions, just let me know.